All right, so looking at this second example now, I wanted you to do this one on your own. So if you are doing this at home, go ahead and pause the video and see if you can do this on your own without me showing you how. So to get the absolute value in the calculator though, you are going to go over here and hit math and then arrow to the right to where it says numeric at the top. And then ABS gives you that absolute value right there. So now it has your absolute value. You can put whatever you need to on the inside of it. So again, pause the video if you need to and go ahead and do this one on your own. Give me the maximum, minimum, and where it's increasing and decreasing. So I've already put it in my calculator. Go ahead and graph it. This is what it should look like. Okay, so here in this case, we have no maximums. We only have minimums here. So remember, the way to find this is go second calc. In this case, we are looking for a minimum, which is number 3, left bound. So my little blinking dot is already on the minimum. If it is not, make sure you arrow to the left or right to get it on the minimum. Then you arrow to the left a few times, hit enter. There's my left bound, there's my little arrow. Okay, now I'm gonna go back and go, so now I'm back on my minimum. Go to the right of the minimum a couple of times, hit enter, go back, and here's my guess. So again, remember that if you're 0.000000001, it's really just gonna be -3 here. And -4.99999 is gonna be 5. So your calculator may not do this, but if it does, you should know how to handle it. Okay, just round it to the nearest what you need to. Now, this one is going to be a minimum, okay, and the minimum is the y value. So it is -5, and it occurs at -3. All right. So now, if we look at this, here's my friend. There's my absolute value friend. I have this ordered pair -5, comma -3, right? And on this side, remember, ignore the arrows. You are going down from left to right. So this is decreasing. This side's increasing, right? And you always go using the x value. So we are increasing from starting at -5 and going to infinity. And then we are decreasing starting at -infinity and going up to -5. All right. Any questions on this one? Okay, so I've had some people ask about the previous problem. So I need to address something in these notes right here. So this one, make sure that if you're using the keyboard on on your computer, so if you're using your keyboard on the computer and you use this for a minus sign, it might give you an error, okay? Because right here, this is the actual minus sign right here on the calculator, okay? If you need a negative, you're gonna have to go and like touch it with the mouse. You're gonna have to click on it with the mouse to do a negative. So this first negative x squared right here, you have to have a negative and not a minus sign. So if it's giving you errors on your homework or on your test, it's because you're using a minus sign instead of where a negative should be, and it's confusing the calculator. So although we know that negatives and minus are really the same thing, the calculator gets confused by its programming. So keeping that in mind, I'm going to get rid of this guy. Okay, let's look at this last example. It's gonna take us a while. Okay, it's gonna take us a little bit to think through this because I'm gonna have this period right here. Think through it. Okay, so a community college has 30 feet of dividers which to set off a rectangular area for a student testing center. If a corner of the math lab is used as a testing center, the partition need only form 2 sides of a rectangle. So this is what they're talking about. If we don't know what to do, draw a picture. Draw a picture. So here's my picture, right? There's the math lab, okay? It's saying that we want to create a testing center within this room. So it's saying we need to make dividers like this in my little blue area, okay? So this is a wall, and this is a wall. So we don't have to use dividers along those walls. All right. If I have, we don't know. Now, here's the thing. We have 30 feet of dividers total, right? We don't know how long either one of these are. They might be the same length. They might be 15 and 15. They might be 10 and 20, right? To give you 30 feet total. We just don't know. But if I say this is L, that's a length, all right? Because right here it says express the floor area in terms of the testing center in terms of the length of the partition. So normally when we look at a rectangle, and remember squares are rectangles, but not all rectangles are squares. That's why I have this. So we have length and width, right? So if I know that together this and this gives me 30, okay? Together those two things give me 30, right? How else can I write this width? So for example, if I know that this is 9 feet long, how long is this one going to be? Yeah, that's exactly right. You just subtract to find it. You know how to find it. Now you just have to make it abstract, okay? So you would subtract. So to get this length, it's going to be 30 minus whatever the length is. Okay, 30 minus whatever the length is. And again, if you needed that, you could have just said, well, length plus width is equal to 30. And we want to get width because it says we want length in the equation. We want length in the equation. So we want to subtract L from both sides. So 30 minus L. Same thing if you need to do it that way. Okay. And then there's this if you need it. Now it says express the floor area of the testing center as a function of the length of the partition. Okay, so that tells me I'm going to need what equation? What equation? Area. Okay, sorry, I didn't hear y'all. Area. Okay, so if I do area of a rectangle, okay, area of a rectangle is equal to what? Just in general, what's area of a rectangle? Length times width, L times W. But it says we want the area as a function of the length. So we only want L's in our equation. So I'm going to do, I'm going to take this friend and I'll plug him in right there for W. Okay. So area is equal to length times, instead of width, I'm going to put W, which is 30 minus L. So W, I'm going to put that equation 30 minus L. All right. Now it says find the domain of the function. Okay, look. To find the domain, the easiest way to find the domain is to graph it, right? So what I'm going to do is I'm going to graph this. But in our calculators, it doesn't use A's and L's, it uses X's and Y's, right? So normally when we look at this, we have Y equals X times 30 minus X, right? Where, so if you need it, just kind of as a reminder here, Y is the area, and X is the length. Okay, so we're about to graph this friend, so we can find the domain. Okay, it also says graph the function, so easy enough. Here, actually, we could think about our domain in terms of like the last things we did. Remember we said domain is all real numbers unless there's an even root or an X on the bottom of a fraction bar. Does this have either one of those? No. So it should be all real numbers, but let's double check that. So I'm going to go ahead and put this in my calculator. You go ahead and do the same thing. So Y equals, okay, I'm just going to turn it off. You can just clear it out of Y1. So I want X times 30 minus X. Now remember, if you're using the calculator on the computer, you cannot type the X in on the keyboard. Found that out. Don't know why, but you can't. Okay. So you'll have to make sure you use this button right here for the X. All right, so now we're going to go ahead and graph it. Well, here's the thing. I can't see anything. So all I can see is that. But let's think about this. When we talk about our domain, let's think through it. Our x value is a length. Okay, if we have 30 feet of dividers, what's the biggest that my length could be? 30, right? Could it be exactly 30? If we had 30, how long would it be my width? 0. So would there be any room for desks? No. Right now, granted, right now we're saying that it could be less than 30. So it could be like 29 and 1 foot. Is that ideal? No, but it is still part of the domain of this function. We can go all the way up to 30, but we can't include 30. Okay, so let's kind of think about this in real terms. So I'm going to look at my window. And our x values, we can go all the way up to 30. So that's what I'm going to put in here. And then I'm just going to see where we're at. So let's go ahead and graph it. All right, so I see this part right here and I see this part right here. So I'm going to make it taller so I can see more. And actually, I might put 40 here just so I can see a better picture of it. And then let's make it 50 right here just to kind of see. Graph it. Oop, it goes even taller than that. So let's see. Let's try. Now, if I were you, I know what's going to happen, so I'm going to say let's try 250. But if you don't, just keep increasing it. If you want to try 500 and then scooch it down, that's fine. 250. Hit enter and graph it. So there's my parabola. Now, when we talk about the domain, it can be what are the valid things for my x values. Now, if this was not a real life situation, it would just be all real numbers because your domain, your x values keep going forever to the left and to the right. But the problem is that really this stuff down here beneath the axes doesn't really exist in real life. We don't have a negative area. That doesn't make sense. So here, my domain, my x value, right? X equals length. So this can go in between, we said it can be up to 30, but it's not included, so it's going to be parentheses. What's the smallest it can be? 0, but it can't be exactly 0, right? So we're going to go anywhere from 0 to 30 and not include 0 because we don't want our length to be 0. Could it be 1 inch? Sure. Is it not ideal? Of course it's not ideal, but it still makes a rectangle. If it's 0, it doesn't make a rectangle. It just makes a line, right? So there's my domain. Now it says graph it. We already did that. Then it says find the dimensions that maximize the area. The y value is the area. We want the maximum. You know how to do that in a calculator, right? So that's all we're going to do is go second calc. We want the maximum, which is number 4. So this happens to be already at my maximum. So I am going to go to the left bound, hit enter, go to the right of my point a couple of times, hit enter, and then go back to my point. There's my guess. Hit enter again. There's my maximum, 15,225. Okay, so my maximum here is 15,225. Remember, this is x comma y. So this is my length. This is my area. So but it's not asking for that. It asks for the dimensions. The dimensions is length times width. So here, the maximum, I'm just going to kind of write up here. The max area is 225 feet squared. The length is equal to 15. How do I find my width? How do I find that width? Just plug it into the equation that you're given, right? Or to the equation that we created, 30 minus L. So width equals 30 minus L, which is 30 minus 15. And that is 15. Okay, so there's my width. These are both feet. Make sure you use the correct units. Okay, it'll ask you for it. So my dimensions, which is really what it asked for, are 15 feet by 15 feet. Okay, 15 by 15. All right, is there any questions on this one? All right, this is the hardest question. You will not have any of these on your homework, but there is one on the review for the test. So or at least you have to set it up. All right, so kind of keep that in mind. There's going to be one on the test. Okay, so let's look at your homework now. Now, if you looked at the homework on the 20th before I got to it, there might not be an attachment if you are reading, if you're listening to this after maybe like 9 or 10 o'clock, there's an attachment on it. Just make sure you look at it. So looking at this, okay, there's about to be, this video is going to be on the notes day 2. So again, you do not have to watch this if you're in class. It's not required if you're in class. If you want to try, I see some of you in first period turned it in. You don't have to if you don't want to, but if you're not in class, you need to watch it and take the notes, okay? Then here is the homework right here. If you're at home, make sure you watch day 1 and day 2 of the notes before you do this. I'll drag day 2 in between these two. Make sure to turn this in when you finish. There's not my math lab homework, it's this, okay? So let's look at this right here. It says, in each row, match the correct extrema, increasing and decreasing to the given problem. Each drag and drop section is worth 4 points. So each of these things down here is worth 4 points apiece, okay? So here, this is the extrema. Extrema or max and mins. I don't think I ever actually defined that word, but extrema or max and mins. There's your increasing options. Here's your decreasing options. So do not put these in a different column. Make sure it goes into the increasing column. So just make sure some of these have both maximum and minimums. Some of them have just maximums. Some of them have just minimums. So all you're going to do is you're going to graph these in your calculator and do the max and min. That's all you're doing, okay? Then you drag and drop it. Ooh, I'm dragging and dropping the wrong thing. There we go. Then you're dragging and dropping this to the correct box. That's literally it. So if we think this goes here, now this isn't right, okay? But that's what you're doing. Same thing, increasing and decreasing goes here, and then decreasing goes up here. Just make sure you put them in the correct column. All right, and then save it, or it doesn't save automatically. Make sure you turn it in to me. You don't have to reattach it, but turn it in, okay? So each one of these is each one of these guys is 4 points apiece, okay? 4 points apiece. Then if you want to, the review is already on my math lab. So if you finish this today, easy peasy, then start working on the review. Tomorrow we are working on the review in class. Then Thursday is test, okay? All of this homework is due Thursday. You also have 1.6 homework that is due tonight. Don't forget about it. Okay, any questions about anything? Did I leave anything out? All right.